Yeah. So welcome Dr. Tuhin Chattopadhyay sir, a celebrated scientist among the top 10 data scientist awarded personality. Dr. Tuhin, we would like to know from you, what is this? So browser explained a lot of things about data science, business analytics, but what are the actual practical use case application? Where is this used? Whether it is in academia, whether it is in the industry, whether it's healthcare, whether it is cyber security, shopping, marketing, where is this actually used? Probably you can share some ideas on that. Where are we in the curve today?
Sure, Dr. Samir. Sure. Mind sharing the deck, please? Mind sharing the slide, please?
Rahul, can you share the PPT, please?
Yeah, so this has been discussed, so we can move to the next one. Yeah. So let me clarify where lies the applications, and honestly, no decisions in business can be taken without the applications of analytics. Gone are those days when the business decisions would have been taken based on experience, based on gut feelings. It doesn't happen like that. It has to be taken on precise decision science methods. So what we are going to do is that we will take 4 or 5 the key business streams or the functional areas of management like marketing, finance, supply chain, systems, retail, and we will figure out that how we can apply analytics in taking the decisions in each of these functional areas. So let's start with the marketing piece. The first piece is the marketing mix modeling. We all know that how marketing mix is critical in generating the sales. Like marketing mix includes the prices, the promotions, but the question that gets answered by analytics is, what's the impact of the price on the sales? What are the impact of the different types of promotions on sales? It can be the traditional media, it can be the digital media. Digital media includes the Google ads, Facebook ads, YouTube ads. YouTube ads can be skippable, non-skippable. Traditional media, we all know, like the TV, radio, newspapers. So what exactly is the impact? And that's very critical because every dollar, every marketing penny matters. And the next one, marketing budget optimization, is the next layer, the next obvious corollary, I would say, from the marketing mix modeling. Because once we know the impact of each of these marketing tools, how I can allocate my marketing kitty, the marketing budget across the different promotional channels. So we use multiple promotional techniques, multiple optimization techniques there. The traditional techniques can be the optimization techniques of integer programming or even the linear, nonlinear programming, but then we use the more advanced techniques nowadays, like genetic algorithms, like the swarm optimization, like the ant colony optimizations. So a lot of optimization techniques comes in allocating the marketing budget to the right avenue so that the sales are maximized. We have to also understand here that it is not that so simple. It's not so simple because the sales and the investment don't take a kind of steep curve. After a certain point of time, the sales increases at a decreasing level, even if you keep investing to the promotional channels. So it's very important to understand the inflection point, and then those becomes the constraints of our model. Customer segmentation is equally critical for the simple reason that one size doesn't fit all. We need to create the homogeneous groups of the customers. Why? Because once we create the homogeneous groups through different modeling techniques, one most popular is the cluster analysis. Once we create that, then it becomes very easy for the marketers to align the right promotional tools with each of the market segments. Because again, as I mentioned, that since one size doesn't fit all, we cannot go for mass marketing. We have to customize our marketing, or to customize the promotions, prices, the branding strategies, marketing strategies around each of these customer segments. Next is the propensity modeling. Again, just goes the next step of customer segmentation. Because once we segment the customers, it's not that each of the customers in a segment has got equal probability to purchase, right? That varies, that changes. That probability to purchase varies even within a segment. So we precisely figured out what's the exact probability of purchase for each of the customers. So accordingly, we take a decision whether to give a discount. If the kind of sales is superfluous, the probability of purchase is more than 90% or 95%, there's absolutely no reason, no point in giving the promotions or the discounts. Similarly, if the probability is less than 30%, no matter how much you promote, they might not convert. So we have to figure out the probability of purchase. If the probability of purchase between 60 to 70% and 70 to 80%, the promotions or the discounts or whatever the strategies are, that should vary, that must vary. So that's exactly been figured out by the propensity modeling, the probability of purchase. A recommendation engine we must have all encountered in all our OTT platforms, even in the online retail stores, that what exactly is the next best product or the next best page the customer is going to click. So accordingly, we promote, we bring out the best possible products, services. There are multiple algorithms there, like content-based filtering, collaborative filtering. We even match the two things, content-based and collaborative, create the hybrid algorithm and create a very sophisticated recommendation engine, which is used by all the organizations, starting from Netflix to YouTube to Amazon. Everyone uses this reco engine. Yeah, next slide, please. Supply chain analytics, again, every step of this field is not possible without the application of analytics. And the mother of everything is demand forecasting. If the demand forecasting is incorrect, then your entire supply chain will go for a toss, in the sense that the customers will line up in the store or in your digital platform, and you don't have the right products to give it. So demand forecasting is the most critical, where every product at every store, not only product, I would say every SKU of every product, for maybe the hundreds or thousands or even millions of stores, or for every customer, it has to be forecasted precisely. Inventory optimization, we all know that we cannot hold the goods, we cannot hold the different products at our warehouses. So the right product should be right product at the right quantity should be stocked, so that our holding cost gets minimum and no customer is dissatisfied by not getting the product. So we have to optimize the product quantity, how much should we stock and how much should be in the pipeline, so that we know that all our customers are catered with the products. Replenishment analytics, again, is very much related with the inventory optimization, that how much to replenish, which one to replenish, when to replenish, where from to replenish. So every decision of that is taken by the mathematics and statistics. Network planning and optimization, what should be our manufacturing unit, what would be our distribution centers, and what should be the store, what should be the location of each of the things, and how should my network flow from the distribution center to the warehouses, to the customers, to the stores. Everything has been planned. What should be my network model? That's been planned in a very precise manner. Transportation analytics, one of the most popular algorithm you must be all knowing is the shortest path algorithm, precisely done by the Dijkstra's algorithm, where we figured out what is the shortest path any of the transportation good or the salesperson should take, so that the cost of traveling, cost of transportation is minimized and my sales gets maximized. There are, of course, multiple variants to it. Variants in the sense the multimodal transportation, like we don't depend nowadays only on one particular transportation mode. There are multiple transportation modes, like the ships, air, road, and what should be the right proportion in terms of the cost, efficiency. So a lot of variables come, and then we develop the models for that. Next slide, please. So financial analytics, again, finance is another area. As I'm discussing, none of the areas for that matter, we cannot take any decision without analytics or without statistics, without mathematics. That's the backbone of business. So credit risk model, whom to give a loan, how much to give the loan, whom to issue a credit card. If I'm issuing, first of all, whether to issue or not to issue. If I'm taking a decision, yes, this person can be issued a credit card, how much should be the credit limit? So we precisely define those things. There are multiple sophisticated algorithms for that, which starts from the very basic decision trees to goes to the random forest, and the most popular one in the industry currently is the extreme gradient boosting. Even the latest deep learning techniques also come, and then we develop very sophisticated credit risk model. Fraud analytics, it's not only determining whether a transaction is fraud or not, but also that has to determine on a real-time basis. Once the credit card gets punched, a lot of variables are there, starting from your location to the location where the credit card gets punched, what was the when was last transaction took place, how far was that, so, and what is the quantum of the transaction, how reliable is that point of sales is. So hundreds of variables go into the transaction part, and on a real-time basis it gets figured out whether what's the probability of this probability of fraud of a particular transaction. Automated trading, gone are those days honestly, where the trader comes, open the portal, and then figure out when to invest, in which stock to invest, whether the stock will go up or not, when to enter the market, when to exit the market. Every small minute decisions are being taken by the algorithms. So it's the entire world is moving towards automated trading, automated algorithms. It's a kind of algorithm driven trading. That's what we say, algo trading. So yeah, analytics persons develop all these algos and then put it into the system. They sell those algos, and then the investors, the brokers, they all purchase the algos, and then they make money out of the capital market. Not only capital, even the derivatives market for that matter. Claims analytics, again, we have to figure out whether the claim is to be approved or rejected. And again, depends on several other variables which comes into place. And we also look at what is the authenticity of those transactions. Actual analytics, the entire insurance industry for that matter, depends completely on analytics. Say you have to define or design a retirement plan policy, a pension plan policy, or even a life insurance policy. What should be the premium? What should be the entire coverage? Everything is designed in a mathematical manner. So analytics has got massive, huge applications in finance. Yeah, next slide, please. Retail analytics. Yeah, that's perhaps one of the sectors I have taken, and that is very close to our supply chain, because if the supply chain is not robust, is not driven by solid analytics, a retail cannot exist, cannot survive simply. So the first thing is the automation of planogram. What is planogram? You must all be knowing that planogram is what particular products to be kept within the store, and at what point of time for which particular customers. Not only products, as I mentioned, it's always at the SKU level. So the entire decisions are being taken in an automated way. So analytics takes a major role, not only in figuring out the SKU sizes, but also the color, the brands, the entire category composition, the category management, the merchandising part. Every decision is automated. So as I mentioned that, supply chain is the mother of this retail analytics. So demand forecasting for every product at every store at specific time frames. What is the expected sales of a particular SKU between 7 to 8 p.m. in a particular store? That's been precisely predicted. If that goes wrong, then you will have dissatisfied customers. Ultimately, the brand value will go down. So simulations of what if scenarios for new product launches. A new product is going to be launched. We actually create the simulation models that yes, if with this kind of price in this kind of geography, what should be the probability of sales and what should be your profit? So if the store opens slightly 1 hour earlier or closes 1 hour later, what is the cost vis-a-vis what's the kind of profit? So a lot of what if scenarios by data analytics were developed. All the pieces of marketing analytics, starting from the pricing analytics, promotion analytics, branding, are very much an integral part of the retail analytics. And we do micro optimizations across assortment. Again, retail space, is like real estate. It's the most precious, most valuable. So what should I have the right assortment in a retail sales so that my sales gets maximized with the minimization of the space? So a lot of this assortment optimization, allocation, pricing optimization continuously takes place. Actually, this happens on a real-time basis. So continuous data gets fed from the POS terminal, how much sales is taking place, optimization algorithm is there, data gets fed in the database, algorithm comes, meet there, decision gets generated, decision gets implemented by the store personnel. So it's a kind of continuous real-time process. Next slide, please. Network analytics, again, another area, IT area, which people think or might have a kind of perception that yeah, IT is somewhat, kind of immune from analytics. No way. One popular algorithm is the leaky bucket algorithm. Even before going to each of them, let me tell you, like there can be complete, you might not even expect when a lot of footprints or the footfalls, digital footfalls might happen to your website. So leaky bucket algorithm is like that is you always create a hole at the bottom of the bucket so that even the inputs are unsteady. But if the hole is a kind of with a measured diameter, with a kind of precise diameter of the hole, then the outflow from that bucket will always be constant. The same thing happens for the customers who comes to your websites or in your portal. You have a kind of steady flow, and then you can ensure that yeah, your server, your entire cloud is kind of stable. So that's exactly the predicting the organizational needs for the bandwidth by monitoring usage patterns with time. So that's how we optimize that with these algorithms, that what should be the right hole of that bucket so that most of my customers get satisfied without any kind of problem. So predicting maintenance of servers is another important thing. Professor Rao mentioned about this Markov chain, MCMC, Markov chain Monte Carlo, or even the Bayesian network. We precisely figured out, yes, what could be the causes, what exactly are the root causes. Maybe B is impacted by A is impacted by C is impacted by D, E, F. So in that, we created a chain, and we can precisely predict, hey, the probability of failure of your server is this much, say 0.657, because there is something happening at C. So we have got the IoT data, that continuous, the sensor data is there, that continuously generates the data, and that gets analyzed, and we always come up with a solution to prevent any kind of failure. Automated security by real-time scanning of input-output data. So that's a very important part. It's not that the security of the network is being taken care by looking at what is coming and somebody's. It doesn't happen like that. It is absolutely automated better. We have got the kind of algorithms which can figure out what kind of images are coming, what kind of codes are coming, and if those images, if those codes by our AI ML algorithms, we found that this is somehow breaching our company policy or organization policy, client policy, automatically that would be restricted. So that's the kind of beauty of network analytics. Obviously, resource allocation optimization, be it the hardware, software, bandwidth, everything has been continuously optimized with, as I mentioned, with very sophisticated algorithms, not by those traditional integer programming. It's by the genetic algorithms, ankylosing optimization, taboo search, swarm particle optimization. We use that, and real-time optimization on cloud architecture for performance maximization. Whatever may the cloud be, AWS, Google Cloud, Azure, everywhere these optimization techniques always monitor the performance of the cloud, because the customers are coming with the pay-per-use model. They always, you have to be ensured as a kind of cloud manager that each of your customers are super satisfied whatever they are paying for. They must be getting all the resources, be it the software or the hardware. So that is possible only when your optimization techniques, optimization algorithms are working continuously on a real-time manner, and accordingly decisions are being automated. So these are the kind of few applications. I would be glad to take questions further. And last but not the least, I would like to say that this is exactly this kind of techniques, topics will be discussed in our conference. So all are most welcome to attend, and we'll be more than happy to walk you through the real life applications in our conference.
Thank you very, very much, Dr. Tuhi. Just one question or curiosity, many years back when Google and internet became so popular, there used to be a question asked, where were so many questions being asked before Google was invented? And the same question to you now, sir. With LIC always existed for more than 75 years, and Apna Bazaar and Sarkari Bandars of the world existed. Actually, science is an old science globally. How was that done without and before AI, ML, and data?
So that's an evolution, partly Professor Rao also covered. The evolution started long back, statistics, marketing research, then data engineering comes. Not only the evolution of statistics, data engineering comes when we have got sophisticated databases, not only about the databases again vary. Now, say, for example, if I have to do for sentiment analysis, I can't have the traditional databases. I require MongoDB. Professor Rao talked about the social media data. So we require the, say, the graph, for graph databases, we require the Node.dj. So the databases evolved, the algorithms evolved. From the traditional classical statistics, we move to machine learning. From machine learning, we move to deep learning. So it's a kind of a combination of the power of data engineering, data science, and then that gives the wing for these businesses to fly.
Perfect. I'm sure in the conference which is there next month, we will cover all of this into separate practical tracks.
Absolutely, absolutely. In fact, I'm also going to take a workshop.
You are taking a workshop.
Analytics. We are going to take that. Yeah.
Super. Thank you very much.
My pleasure.
So when we have such a phenomenal conference happening in India, in Bangalore next month, details are there in the chat windows. It is also important to know who are the people who are doing this conference. What is the credibility? What is this ISDSI Global?